All right, what a beautiful moment you have with us today. We are talking about Laplace equation and harmonic function. This is Maths 201, a CBT organized exam. Is that correct? All right, and we discovered that the Laplace equation tells us that we are treating second order. So we said the u of xx plus u of yy is equal to 0. That means we call this a Laplace equation if it is of two dimension. Why is it two dimension? Because you are dealing with two independent variable system. Now, we said if w is equal to three independent variable system, w of xx plus w of yy plus w of zz is equal to 0. That's the Laplace equation of three dimension. Three dimensions because we have three independent variable system. And you remember in one of our classes we spoke that, or we said that the number of independent variables present in the system tell us the dimension of that equation. Is that correct? And we found out that a function that satisfies a Laplace equation is said to be harmonic. So this is where your CBT question comes out. You can be asked which of these represent an harmonic equation, or which of these is known as an harmonic equation. You say a function that satisfies Laplace equation. Is that correct? So without wasting much of our time, we're going to be looking at one of the questions. It says show that u equals e to the power of minus 2y cos 2x is harmonic. We want to prove this. And so what do we do from here? Remember, we have two independent variables in this. We have x and we have y. We have y and x, so x and y, anyone you like, the arrangement you want to give. So let's start. So let's differentiate with respect to it, u of x. Let's differentiate u of x. Now we are pretending, because we are dealing with partial derivative, we are pretending we're not seeing this. We're not seeing the e to the power of minus 2y. We're going to pretend we didn't see it. So let's differentiate cos 2x. If you differentiate cos 2x, I believe you're going to have a minus 2 sine 2x. Is that correct? Minus 2 sine 2x. Yeah, a minus 2 sine 2x. And then you multiply that with this person that you covered. And so you're going to have minus 2e minus 2y sine 2x. Is that clear? So what did I simply do? I pretend as if I didn't see this guy, e to the power of minus 2y. I didn't see it. I'm just seeing cos 2x. I just pretend as if I'm only seeing cos 2x. And so when I differentiate cos 2x, I'm going to have minus 2, because differential of cos is minus sine. Is that clear? So I'm going to have minus 2 sine 2x. I'll repeat what is there again. Do you understand? So when you have minus 2 sine 2x, then use it to multiply the nonsense that you pretended as if you did not see before, e to the power of minus 2y. So I'm going to have minus 2 e to the power of minus 2y sine 2x. I hope that is clear. I want to believe that is clear. Okay. Now that you have it as this, now let's do with respect to y. Since we are dealing with two independent variable system. We are dealing with two independent. So with respect to y of this function, now we are going to pretend as if we didn't see this guy, this cos 2x. So we are dealing with this guy this time around, e to the power of minus 2y. And so when you are differentiating, this minus 2 comes down. This minus 2 just flips down, and we have minus 2 e to the power of minus 2y. Then repeat what is there, cos 2x. Remember, we pretend as if we did not see cos 2x before. We just cover it and then differentiate this part. Do you understand me? And so when we differentiate that part, then we multiply it by what we pretended as if we did not see before. So now we now have uxx. We want to redifferentiate. So at this point, we redifferentiate. At this point, we redifferentiate. So what is u of xx? We want to repeat that cycle. So we're going to redifferentiate this guy. Remember, Laplace function says u of xx, u of yy. So we are dealing with second orders. Second differential. Do you understand? Redifferentiation. When you say u of xx, it means whatever you have as u of x, redifferentiate it. When you say u of y, and you want to do u of y, it means you have to differentiate this guy again. Do you understand? So when we have u of x and you want to differentiate again, you are going to start from here because you are differentiating this man. This guy is an illustration of the differential of this guy. Is that clear? And so when you do that, so this is sine. We are covering this because we are dealing with u of x. We are differentiating with respect to x. So we cover this, and then you have sine 2x. So if you differentiate sine 2x there, you're going to have a minus, you're going to have a cos, or you're going to have a 2 cos 2x. Yeah, you're going to have 2, this 2 comes out. Then if you differentiate the sine, you're going to have a cos. So you're going to have 2 cos 2x. And so when you multiply 2 cos 2x here, that you have here, multiply it by what you have here, what you're going to be having is minus 4 e to the power of minus 2y cos of 2x. Did you see that? Cos of 2x, cos 2x. Now, again, because you did u of x, you need to do u of what? Y. U of y. And so when we differentiate u of y, we are differentiating with respect to y now. So we're just going to pretend as if we didn't see this guy so that we can differentiate this. So minus 2 is coming down. Minus 2 multiplied by minus 2, I believe that's 4. Right? That is 4. Yeah. I believe that's 4, right? That should be 4. Minus 2 multiplied by minus 2, that's 4. Yeah. So as we earlier saying, we said minus 2 multiplied by minus 2, that is 4, right? So we have 4 e to the power of minus 2y, and then we multiply by what we see there. Cos of 2x, cos 2x. Now, having said all of these things, let's clean this part quickly. You find out that we said u of xx, by the time you add it with u of y must be equal to 0. Is that true? In this case, is that true? Is that a true statement? So let's check. We have minus 4 e to the power of minus 2y cos 2x. If you add that up with 4 e to the power of minus 2y cos 2x. Oh, wow. So it's 0. It's 0. Wow, beautiful. If we add this to this, they will just cancel out. That's 0. Oh, beautiful. That's wonderful, you know. That's wonderful. So it is a Laplace function. It is a Laplace equation. That means it satisfies an harmonic function. Harmonic function. That's good. That's beautiful. So that's what we need to know. When we talk about a Laplace equation, we say u of x. If it is a 3 independent variable system, let's say for example it has u as it approaches, for example, e to the power of minus 2y cos 2xz. You understand? So now we're having x, y, and z. So we are going to be proving that this u of zz is equal to 0, as long as it's a 3 independent system. But because this question asks us 2 independent variables, which is x and y, that is why we are operating u of xx plus u of yy is equal to 0. Very interesting. Wow. Okay, let's look at another example.